So the other skill that we need to have is we need to be able to sketch a reciprocal function when we don't even know its equation, but we're just looking at a graph of it. So to do this, we need to just think about shapes, and we need to think about those truths that we've already seen about reciprocals. So here are some key points that can help. We know that any zeros, and by zeros I mean x-intercepts, that are on the original graph are going to be vertical asymptotes of the reciprocal graph. And that's because if we've got a section on our graph, we might be going through like this, and we can see that that y equals 0 at that value of x, then when we flip that x value of 0 upside down, we've got something over 0, and that makes an undefined area. So that's going to give an asymptote at that value of x for the reciprocal graph. And similarly, if we've got a vertical asymptote, then that's something that couldn't be done because it was something being divided by 0. When we flip it up the other way, it's okay. It becomes 0. So asymptotes become zeros, zeros become asymptotes. Large magnitude numbers become very small numbers and vice versa. So we've already seen that just with the way reciprocals behave generally, but we've also seen that the sign stays the same. So a really large positive number will become a really small positive number, a tiny, tiny fraction, but it'll still be positive, and same if it's negative. When one graph intersects the line y equals plus or minus 1, so does the other. Now, let's think about why this might happen. Let's say we've got some graph, perhaps it's a basic sort of parabola like y equals x squared minus 1, and it's just been shifted down minus 1. If we flip that thing upside down, then its equation would be y equals 1 over x squared minus 1. Now think what will happen when x is 0 here. Here when x is 0, y was minus 1, so it went through that point. But here when x is 0, we've still got 1 over minus 1. We've still got negative 1. Now why is this happening? Well, the number negative 1 itself, when you flip it upside down, you still get negative 1. And similarly, when you flip 1 upside down, you still get 1. So any time that you've got a graph going through that line y equals minus 1 or y equals 1, you're going to get your reciprocal graph actually also going through that point as well. Other things we need to consider is that if y, and I've written here f of x, but if y is approaching infinity, in other words, if we've got a section of the graph where it's just heading onwards and upwards in some sort of diagonal way like this, it could be a straight line, it could be concave up, concave down, but as long as it's sort of heading onwards and upwards, if that's happening, then we know that the reciprocal graph is going to tend towards 0, because flipping a massive number upside down gives us one that's as good as 0. It's never going to actually get there, but it's going to approach 0. So this is going to make the reciprocal graph have some kind of horizontal asymptote actually on the x-axis. Okay. Other things to consider are that when you graph the key points first, this is going to be the most helpful. So for our first example here, we've got some kind of parabola. We haven't actually been given its formula. Now, perhaps you can work it out using some of the clues, but that's not the skill that we're looking at today. We just want to come up with the reciprocal function, and we want to be able to draw something that looks roughly right and has the basic key points. So the most important key points on this parabola are the zeros, or the x-intercepts. Now, we want to take the y value, because here we have y equals f of x, and we want to sketch y equals 1 over f of x. So whatever y equals, we want to flip that upside down, because flipping f of x upside down is the same thing as flipping y upside down, because y was f of x here. Does that make sense? So if you flip 0 upside down, what do you get? Something divided by 0. You can't have that. So on our graph down here, when x equals 5 or negative 5, we've got a no-go zone. The graph cannot exist there. So we've got a vertical asymptote here and here. All right, what else do we know? Well, there's a known point here, negative 3. What happens when you flip negative 3 upside down? It's really negative 3 over 1. And when you do that, you get minus 1/3. So our intercept here, if this is 1, will be at minus 1/3, so around about here. Okay, so we know it goes through there. All right, what else do we know? Well, we know that where it goes through the line y equals negative 1, which is around about here. So let's say over here and here, if I just drew a line through here, it's not an asymptote, I'm just drawing it as a dotted line. If we look at this point here, it's something negative 1. what would it be? Let's guess, like maybe 4.5 or so. Well, we know that here when x is 4.5, y is -1, this graph's going to go through the exact same point. So if I go across to like around about 4.5, and I'm sort of guessing, but that's fine for what we're doing here, and -1, I can put a dot, and that's because flipping -1 upside down gives me -1. So I can see that my graph is going to go through there. Let's make our graph in blue. And the same thing's going to happen over here at, say, about -4.5, -1. So we've got a dot there, we've got a dot there, and we know it goes through here. All right, now what happens out to the right-hand side of the 5? The y value gets really big, doesn't it? It goes onward and upward forever. So what is our reciprocal going to do? If y was approaching infinity, then 1 over y must be actually approaching 0, right? So that means that as we move along this way, we're approaching 0. Now, is it going to be positive or negative? Well, if the graph is positive, the reciprocal is positive. So it means that as we go on to bigger and bigger x values, we're going to have some kind of asymptote out here, and our graph is going to approach 0 like that, but never actually reach it. Remember, this one's approaching infinity, so this one's going to approach 0. This one's positive, so is this one. Let's think about what happens when x is just a little more than 5. Well, here when it's just a little more than 5, we've got a very small number. What happens when you take a very small number, like, I don't know what it might be, maybe a quarter, something like that. When you flip a quarter upside down, what do you get? 4, quite a big number. What if you get just even closer to the 5? What about if you had like just a smidgen across from the 5? It would only be up just a little bit. Maybe the y value might be, I don't know, 1/100th, a tiny fraction. What would happen when you flip that upside down? You get 100. Okay, can you see where I'm going here? The closer we get going down this way towards the 5, the smaller the y value. It's going to become a tiny, tiny fraction before it actually hits 0. So we can see that the reciprocal is going to go shooting up infinitely and glance towards this asymptote, never actually meeting it, but always going onward and upward. And the same thing is going to happen over here, isn't it? So here we've got a y value that's just very, very small. Flip that upside down, it's going to be one that's very, very big. And we're going to have a similar situation heading out this way. We also know that because y is positive here, it must be positive here too. And because it's heading towards infinity this way, it's going to be heading towards 0 this way. Let's make this come out a little bit longer so that we can see what we're doing. So we've got some sort of asymptote going out that way. All right, that just leaves the section in between for us to think about. Well, what do we have just a little to this side of the 5? If we just go a tiny little way across, what sort of y value have we got? Maybe negative a tiny fraction, -1/10 or something. Flip that upside down, -10. What if it was really close to the 5? It'd be like negative a tinier fraction. Well, it's going to be a really larger negative number. So we can see that as we're very close to the 5 and just to the left-hand side of it, our reciprocal graph is going to go infinitely negative down there. So it's going to go shooting down. And it's going to do the same thing over here, isn't it? Okay, so we're sort of getting a bit of a feel for it. It's going through this point. It looks like if we took a guess, it might do something like that. Oh, I've made it look a little bit sort of not very flat there, but some kind of flattish curve. And sure enough, by taking a bit of a guess and reasoning that we've got a smooth transition here from this point to this point, so it's probably a smooth transition from our known points here to the other known points, this idea of finding your key points and then sort of guessing the shape in between is not a bad strategy. Now, once you've got it in there, you can sort of have a look at it and see if it makes sense. Let's take a point like maybe here and just have a bit of a guess. Halfway between 0 and 5, what's happening? Well, I'm guessing that we've got a y value of, what do you think, maybe like -2. Well, what happens when we flip -2 upside down? We get -1/2. So that means halfway between here and here, we wouldn't be at -1/3, which is our intercept, would be at -1/2, which is just a little low down. And sure enough, that looks pretty much like what we've drawn. So that idea of taking a guess is really quite helpful here. And then you can take individual points and just sort of guess the rough distances that they'd be, take the reciprocal of them, and then graph those points, join your points up.